A very warm welcome and thank you so much for joining me for this explainer. I'm absolutely delighted to be your host today as we dive into what is, quite frankly, the most disruptive generative AI model of 2026. Now, usually I'd start by laying out a meticulous agenda for our time together, but today, well, we're tossing the traditional playbook right out the window. We're bypassing the usual pleasantries to preserve a truly grand surprise. So, do settle in, because the landscape of digital creation has just shifted right beneath our feet. To really understand the magnitude of this shift, allow me to take you back to a rather intriguing little mystery. Back in early April 2026, an unnamed, completely anonymous model suddenly dropped onto the artificial analysis video arena. There was no grand announcement, no glossy marketing campaign, and certainly no distinguished corporate logo attached to it whatsoever. It simply appeared. And instantly, the AI community was left utterly astounded. Everyone was asking the exact same question. Who on earth built this? Was it Google? Perhaps a stealth research lab? The outputs were so genuinely different from anything else out there that it sparked an industry-wide detective hunt. And this number you're seeing right here is exactly why the community was in such an uproar. 1416. That is a staggering, record-breaking Elo score achieved on the image-to-video track. Now, what makes this so remarkable is that the artificial analysis video arena is a blind test. Viewers watch two videos side by side without knowing the creator, and they simply vote on the best one. This extraordinary score wasn't just a brief fluke either. It was maintained across nearly 15,000 blind votes before anyone possessed even the slightest inkling of the creator's identity. It cleared the top of the leaderboard by a margin that is, quite honestly, practically unheard of in this space. The mystery, thankfully, was short-lived. On April 10th, the curtain was drawn back, and Alibaba formally claimed the model. They revealed it to the world as Happy Horse 1.0. And I should point out, this wasn't the work of ambitious newcomers. It was built by a veteran team tucked inside Alibaba called the Tao Tian Future Life Lab, spearheaded by the brilliant Zheng Di, a gentleman who previously led the highly respected Kling AI video team. They brought years of distinguished experience to the table, and it culminated in a model that fundamentally changes how we have to think about generative video.
Part 1. The Native Audio-Video Secret.
To truly grasp this architectural marvel, you really have to shift your mindset. You see, using previous AI generators was rather like being a silent film director. You pointed a camera, captured the motion, and then painstakingly figured out the sound later. Happy Horse, on the other hand, requires you to simultaneously record with a boom mic. So, how does it achieve this? The answer lies in a unified self-attention transformer. We're talking about a roughly 15 billion parameter model structured in a 40-layer sandwich layout. Unlike older models that essentially bolt a separate audio generator onto a video generator, Happy Horse uses one single sequence. Text, image, video, and audio tokens all share the exact same stream. There is absolutely no separate audio submodule here. The visual and the auditory are born together in the exact same mathematical breath. It's quite elegant.
The sheer breadth of what this unified approach unlocks is truly remarkable. Because it operates in a single pass, Happy Horse natively generates synchronized Foley. Think of the crisp sound of footsteps matching the exact microsecond a shoe strikes the pavement. It conjures lush, ambient background sounds perfectly suited to the visual environment it just created. But perhaps most impressively, it features natively trained lip sync across 6 different languages. We're talking English, Mandarin, German, French, Japanese, and Korean. No post-production dubbing required whatsoever. It simply effortlessly speaks.
Naturally, you might assume that such a complex, unified process would take an absolute eternity to render. Yet, the reality is quite different. 38 seconds. That is the time it takes to generate a glorious 1080p video clip on an NVIDIA H100 GPU. Behind the scenes, the engineering team achieved this through an elegant 8-step DMD2 distillation process. Essentially, it's a highly optimized shortcut that completely does away with the heavy computational burden of classifier-free guidance. For you, the creator, this translates from dense technical jargon into pure, unadulterated speed. It makes iterating and testing prompt variations a wonderfully practical endeavor rather than a painful waiting game.
Part 2. Under the Hood. API Mechanics.
Now, for the developers and technical architects joining us, let's examine how to harness this power to build a robust integration. Because video generation is still computationally intensive, taking perhaps a few minutes depending on server load, Alibaba's DashScope platform utilizes an asynchronous workflow. It's an elegant 2-step polling process. Step 1 involves creating your task and making absolutely certain to include the x-scope async header set to enable. Step 2 is taking the task ID returned to you and politely polling the server for the results. And do note that Task ID remains valid for a full 24 hours, giving your systems ample time to retrieve your masterpiece.
The crucial point here is understanding the boundaries of the canvas. The API enforces strict, yet highly sensible technical limits. For instance, if you're feeding it a reference video, the file size must not exceed 100 megabytes. The input video duration can range from 3 to 60 seconds, but the system will automatically cap the generated output to a maximum of 15 seconds. And critically, when passing your media assets in the JSON array, there must be exactly one video element present. Precision in your requests, as always, guarantees the finest results.
Part 3. Happy Horse 1.0 versus Seed Dance 2.0.
As impartial observers of this technological renaissance, we really must compare Happy Horse to its most formidable rival on the leaderboard, which is ByteDance's magnificent Seed Dance 2.0. The divergence in their design is quite fascinating. Both models are extraordinary, yet they take fundamentally different philosophical approaches. As we've seen, Happy Horse 1.0 utilizes a unified single-stream architecture, meaning all modalities share one continuous token sequence. Seed Dance 2.0, conversely, employs a dual-branch diffusion transformer. It features one dedicated branch for video and a completely separate dedicated branch for audio, which are then meticulously synchronized via cross-attention modules. It's the classic engineering debate, isn't it? A master of all simultaneously versus highly specialized branches conversing at lightning speed?
So how does this actually play out in the blind tests? Well, the leaderboard matchup reveals a splendid nuance. Happy Horse's unified architecture firmly wins on raw visual motion fluidity, boasting an ELO of 1389 against Seed Dance's 1269 in silent video. Its motion realism is simply a step above. However, Seed Dance's dedicated dual-branch design grants it a slight, yet distinct edge when it comes to highly complex, emotive audio synchronization. Think background music dynamically adapting to the tension of a scene. In short, Happy Horse is the king of fluid visual motion, while Seed Dance remains a titan of complex cinematic soundscapes.
Part 4. Writing audio-first prompts.
Understanding the architecture is absolutely fascinating, but mastering its application is where the true artistry lies. To achieve genuine cinematic immersion with a model that listens as well as it sees, we have to rewrite our approach and layer our audio descriptions into 3 distinct tiers. We're no longer just describing a photograph, you see. We are composing a symphony. First, the foreground. This is your dominant sound, the direct dialogue or the primary sound effect. Second, the midground. These are the secondary textures, the Foley work like rustling fabric or distinct footsteps. And finally, the background, the ambient murmur of a crowd or the distant howl of wind. By explicitly instructing the model across these 3 layers, you provide the unified transformer the precise tokens it needs to build a rich, believable auditory world.
Let's look at a superb example sourced directly from the testing labs. Just read this specific cue. A Thai street food vendor cracks 2 eggs onto a sizzling flat top. Audio, sizzling oil and egg whites hitting the grill. Sharp spatula scrape on metal, distant crowd chatter. Notice how highly specific the text is. The visual action of the spatula is directly paired with the audio cue of the sharp scrape on metal. This intertwining of visual and auditory cues is the absolute precise formula for generating magnetic, ASMR-grade social media content in a single pass.
Here is another exquisite prompt template, this time tailored for high-end commercial work. We describe a luxury chronograph watch, complete with macro details and studio lighting, but the real magic is in the audio directive. Audio. Individual water droplet impacts on glass, a crisp, mechanical click as the crown is pressed. When that precise mechanical click perfectly aligns with the visual movement of the watch's second hand, you realize this model can completely replace a highly expensive physical studio shoot and a dedicated folio artist. It is, quite frankly, breathtaking.
To summarize our actionable wisdom for you today, do keep these best practices firmly in mind. First, be concise. Aim to keep your prompts under 100 words so the model's attention isn't diluted. Second, front-load your main subject and action. Those first 15 words are absolutely paramount. Third, use highly specific camera terminology. Don't just say cinematic, say whip pan or slow push-in. And finally, always explicitly name the visual style, whether that's 1990s VHS grain or crisp product photography. Command the model with precision, and I promise you it shall reward you handsomely.
We have journeyed through the architecture, the leaderboards, and the sheer artistry of this groundbreaking technology. Happy Horse 1.0 has single-handedly eliminated the arduous bottleneck of audio synchronization, empowering creators in ways we could only dream of just a year ago.
The barrier between your imagination and a fully realized, sounding, moving scene has literally never been thinner. So I leave you with this provocative thought to ponder today. When video and audio generate as a single, beautifully unified entity, what will you create? Thank you so much for joining me for this explainer, and I eagerly anticipate seeing the marvelous worlds you will build.